Imagine a massive supercomputer spending, like millions of years, calculating the ultimate answer to life, the universe, and everything. The gears turn, the galaxies spin, and finally it spits out a single number, 42.
Right, the ultimate punchline.
Exactly, from the Hitchhiker's Guide to the Galaxy. But right now, in the real world, that exact scenario is basically the nightmare keeping enterprise software engineers awake at night. So, welcome to the Deep Dive.
Glad to be here for this one.
Yeah, our mission today is answering a question on pretty much everyone's mind. Are we heading toward a future where we just talk to our computers in plain English, or, is writing actual code still the only way to build the future? Like, should you be learning Python or just talking to chatbots?
I mean, it is the defining question of the current tech landscape, because the answer completely shifts how you need to build out your tech stack, how you manage your teams, even how you think about system architecture over the next decade.
Oh, for sure. We're looking at this amazing research document today, The Language for AI Systems, and it's all about this collision between human linguistics and computer syntax.
Yeah, and it is arguably the most complex engineering challenge of our time.
Okay, let's unpack this. I want you to imagine a world where coding looks less like the Matrix and more like, well, just having a conversation with a coworker.
It's a wild shift to wrap your head around.
It really is. But to figure out where the future of coding is going, we first have to look backward at how we got here. Because technology always trends toward making things easier for you, the user.
Precisely. If we look at the evolution of programming, it's this steady, relentless march away from the bare metal. I mean, interacting with a computer used to mean literally flipping physical binary switches on a front panel.
Just inputting zeros and ones by hand. Sounds exhausting.
It was. And then came paper tape, punch cards, teletypes, and eventually, the keyboard became king. We shifted from machine code to assembly language to high-level programming languages.
Right. Each step moving humans further and further away from the raw hardware, the bare metal of the processor chips. It's kind of like driving a modern car.
Oh, that's a good way to look at it.
Yeah. You don't need to know how to manually inject fuel into the engine cylinders. You just press the gas pedal. That's the abstraction. And now AI is offering us a self-driving car.
Exactly. We've seen this before, right? The rise of killer apps like word processors or desktop publishing. Yes, spreadsheets changed who could use computers. It made them essential for everyone, not just highly trained engineers. AI is currently in a very similar killer app stampede.
So it's democratizing access all over again.
What's fascinating here is how natural language interfaces are simply the ultimate, most recent layer of abstraction. We've gone from physical switches to syntax, and now we're trying to go from syntax to pure speech.
Which sounds like a dream. But, and this is a massive but, if abstraction is the ultimate goal, why don't we just entirely replace coding with plain English right now? I mean, rip out the code bases.
Well, because of the glaring flaw in human communication. We are terribly inherently imprecise.
Oh yeah, we're messy.
We really are. Programming languages require strict grammatical and syntactical rules to compile or run. Human speech often just ignores these rules completely.
Right. We use fragments, we trail off.
Exactly. Direct natural language input has this fluidity that leads to massive misinterpretation. Which brings us right back to your example of the number 42.
Oh, right.
To a programmer, asking for the answer to life, the universe, and everything is the ultimate example of a poor requirement. It's a badly formatted prompt.
Because it's too vague.
Right. And even current LLMs, when they generate code from natural language, they often write less efficient, more bloated code than a highly trained human programmer would.
Okay, wait, let me push back on that a little bit on behalf of the listeners.
Yeah.
Because humans communicate with each other just fine most of the time. Like,
right.
Why can't an AI just use context clues like we do?
This raises an important question. Do humans actually communicate fine most of the time? Think about the stakes.
Well, I mean, misunderstandings definitely happen.
They happen constantly. Misinterpretations lead to conflict all the time. That's exactly why we rely on highly trained diplomats for international agreements, right? To minimize those misunderstandings.
Oh, wow. That's a really good point.
Yeah. Relying purely on natural language for critical software is incredibly risky. You can't have a banking system guessing what you meant based on context clues.
No, you definitely don't like your bank operating on vibes. And here's where it gets really interesting, because human language isn't just messy today. It's going to change entirely by tomorrow.
Yes. The technical term for this is linguistic drift. Human speech patterns are constantly evolving.
So the moving target for the AI.
Exactly. We see constant lexical innovation and semantic shift. New jargon gets created, old words change meanings, and that leads to direct AI misclassification.
What about when people speak multiple languages at once, like using Spanglish?
Oh, mixed languages are a huge challenge. People naturally mix languages, using English and Spanish words in the exact same sentence. Handling that requires incredibly complex mixed language processing.
And dialects, or slang. Like, regional differences could trigger massive sentiment analysis errors in AI systems. I just love the idea that teenagers inventing new slang on the internet could literally break an enterprise software system.
It absolutely happens.
Yeah.
If the AI isn't prepared for the new slang, it'll completely misunderstand the sentiment.
So how do you even fix that?
It requires rigorous solutions. You have to do continuous retraining of the LLMs, and you implement retrieval augmented generation.
Okay, remind us how RAG works in this context.
Basically, it fuses static LLMs with dynamic, constantly updated knowledge stores. So the AI pulls the most recent definitions before it answers. Plus, you need guardrails.
Like what kind of guardrails?
Things like bias audits and automated rollback mechanisms just to prevent any malicious linguistic drift from breaking the system.
Wow, okay, so if natural language is way too chaotic for the back end, but, it's way too user-friendly to just abandon, what's the compromise? Like, what is the architectural solution here?
The solution is a layered architecture. The research document lays out 6 specific recommendations for building this hybrid system.
Let's go through them. Number 1.
Layered interaction. The front end uses natural language and voice, but the middleware uses function calling schemas and our RAG. And then the back end requires typed APIs like Python, Go, or TypeScript for security and performance.
Okay, it's sort of like a busy restaurant, right? You, the customer, order in plain conversational English on the front end.
I like that, yes.
And then the waiter translates that into a specific shorthand ticket, that's the middleware. And the kitchen executes the dish using precise, rigorous culinary measurements. That's the back-end Python or Rust code.
That is a perfect analogy. The second recommendation is continuous learning. You need nightly RAG updates and RLHF reinforcement learning from human feedback.
So humans are reviewing the AI's mistakes.
Exactly, paired with human review to keep the models aligned with how norms are evolving. Third is standardized interfaces. You have to define JSON schemas for callable functions.
And you publish those as OpenAPI or Swider docs, right?
Yeah.
So the LLMs and the code stay in sync?
You got it. Number 4 is robust monitoring, deploying drift detectors that specifically look for lexical changes and safety violations.
Okay, what about number 5?
Keeping a code-first baseline. This means having a golden implementation of your critical workflows written in compiled languages like C++ or Rust.
So it's a safe deterministic fallback if the AI gets confused.
Exactly, it prevents system crashes. And finally, number 6 is governance. You must log every natural language request, every LLM function call, and the system response in immutable storage for auditing.
That makes total sense if we connect this to the bigger picture.
Well, if we connect this to the bigger picture, this hybrid approach gives businesses the best of both worlds. You get extreme ease of use for non-technical stakeholders, combined with ironclad security and governance under the hood.
Okay, so we know the architecture needed today. But how is this actually going to play out in the market over the next few years? The source document has a really specific timeline.
It does. Looking at 2026 to 2027, we'll see widespread adoption of LLM-driven function calling. It's going to become the definitive bridge between natural language interfaces and typed APIs.
So that's the immediate future. What about 2027 to 2029?
That's the era of the edge. Adaptive LLMs will emerge that update incrementally on device.
Oh, wow. So not processing in the cloud.
Exactly. Running locally drastically reduces latency for edge applications that rely on voice.
That's huge. No more waiting 5 seconds for your smart car to turn on the wipers after you ask it to.
Right. And then, looking at 2030 and beyond, we enter the phase of code plus prompt environments.
Wait, code plus prompt, what does that actually look like?
Developers will write type-annotated prompts, basically using English to describe the logic, but embedding strict variable types. The environment compiles that into deterministic function call graphs.
So it totally blurs the line between human language and computer code.
Completely.
So what does this all mean for you? If you're listening right now, should you bother learning Python today, or should you just practice talking to chatbots?
The takeaway from the research is very clear. Natural language will not replace programming languages. Instead, it reshapes how we specify AI behavior.
So the bare metal still matters.
Absolutely. Programmatic languages remain indispensable for low-level integration and performance. But the systems that can translate human speech into robust, version-controlled function calls, those will dominate the future.
Man, What a journey today. We went from flipping binary switches on bare metal to the messy fluidity of human slang to this future hybrid world where plain English seamlessly triggers rock-solid C++ code.
It's an incredible evolution, and it really shows that staying relevant means adapting as human communication itself evolves.
Truly. And, I want to leave you with a final provocative thought to mull over on your own.
Okay, let's hear it.
We've talked so much about how interacting with technology requires intense semantic precision, right? To prevent the AI from misinterpreting you.
Right, because of all the ambiguity we discussed.
Exactly. So, if the future of interacting with tech requires such intense linguistic precision, will the greatest programmers of the next decade actually be the poets, the novelists, and the linguists?
Oh, that is a fascinating thought.
Right. If words are the new code, mastering the English language might just be the most valuable technical skill you can possibly acquire.
It changes how you look at a liberal arts degree, that's for sure.
Definitely. Something for you to ponder next time you're crafting the perfect prompt.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.